Today we are going to be looking at section 5.3, which is solving trigonometric equations. This is section 5.3 in your textbook, so feel free to reference that as well as I go throughout this lesson, or if you have any questions. So when we're solving trig equations, it's going to be very similar to solving algebraic equations. We're going to use a lot of the same standard algebraic techniques in order to isolate the trig function that is seen in the equation, and then from there we will solve for whatever the variable is, whether that's x or theta or any other type of variable that is going to actually represent our angle measure. And we're going to solve for that using what we know about the unit circle or what we know when we were graphing trig functions. So you may want to have your unit circle handy as I go throughout this lesson. So let's look at the first example here. So first example, we are going to solve 2 cosine of x minus 1 equals 0 for the interval of x being between 0 degrees and 360 degrees. So we are solving for x is an angle, and we are only looking at one rotation of the unit circle or one period of this cosine function. First, we are going to start by getting cosine of x by itself, isolating that trig function. We will start by first adding 1 to both sides, and we get 2 cosine of x equals 1. Then we're going to divide by 2, and cosine of x equals 1/2. So we start by isolating that trig function, in this case cosine. And now we're going to think about our unit circle, and you're going to look at your unit circle and look at what angles is my cosine value 1/2. So looking in quadrant 1, the first angle that we get when cosine is 1/2 in degrees, since we're looking in degrees here, is 60 degrees. So at 60 degrees, cosine is 1/2. In quadrant 2, cosine is negative, so no angles there because we want a positive. In quadrant 3, cosine is also negative. In quadrant 4, cosine is positive again. At 300 degrees, cosine equals 1/2. So you have to think about this like when we were thinking about the inverse functions from a few units ago. You're looking for the angles that are giving me this value. So 60 degrees and 300 degrees, that would be my two solutions for this trig equation. I could substitute those solutions in to that trig equation and they would satisfy the equation. Let's look at another one. So this time we're solving for sine of theta plus square root of 2 equaling negative sine of theta, and we're looking at the interval 0 to 2 pi. So now we're looking at radians, but we're still looking at just one period of the function or one revolution of the unit circle. We're going to start by, so we have sine on either side of the equation. Let's get those together by subtracting this sine to the other side. So I get square root of 2. Negative sine plus a negative sign is going to give me negative 2 sine of theta. We're going to divide by that negative 2, and we get negative square root of 2 over 2 equals sine of theta. So we isolated our trig function first. Now we're going to solve for theta, that's our variable, and we're looking at where does sine give me negative square root of 2 over 2. In quadrant 1, sine is positive, so no values there. In quadrant 2, sine is also positive, so no values there. In quadrant 3, sine is negative. Our first angle is 5 pi over 4. At 5 pi over 4, sine is negative square root of 2 over 2. And 7 pi over 4 in quadrant 4. Those would be our two solutions to this trig equation. So sine of 5 pi over 4 is negative square root of 2 over 2. Sine of 7 pi over 4 is negative square root of 2 over 2. Okay? Third one. So now we're solving square root of 3 secant theta minus 2 equals 0. And notice how this one's termed just a little differently for solutions over the interval 0 to 2 pi. So this means the same thing as number 2. It's just using interval notation this time. It's still saying we want our solutions to come to be from between 0 and 2 pi. So they're going to be radian answers, 1 revolution of the circle. So let's start by isolating this variable, or this trig function of secant. We'll add 2 to both sides. I get square root of 3 secant theta equals positive 2. Now we'll divide by the square root of 3. And I get secant theta equals 2 over the square root of 3. Well, we don't work with secant a whole lot, but we do know from last chapter, Unit 8, our identities chapter, we do know what its reciprocal is. The reciprocal of secant theta is cosine theta. So if secant theta is 2 over square root of 3, its reciprocal would mean that cosine of theta is square root of 3 over 2. And we can now use this to help us look and see what our angle measures would be. So here we're looking at what angles does cosine equal square root of 3 over 2. So in quadrant 1, that's going to be pi over 6. Again, we're looking in radian measures. In quadrant 2, cosine is negative, so no values there. Quadrant 3, cosine is negative, no values there. Quadrant 4, 11 pi over 6. Cosine would also be equal to square root of 3 over 2. So those would be my two solutions for this trig equation up here. Okay? And for this screencast, let's do one last example. We are going to solve 2 cosine squared of x minus 5 cosine of x plus 2 equals 0 for, again, solutions over this interval between 0 and 2 pi. Okay, this really relates back to last chapter when you think about the identities chapter. At the beginning of the chapter, we did a lot of factoring these trig equation or these trig expressions at the time. This is where it becomes really useful. So at the time when we were factoring, I told you guys if you needed to, change it just to x's and factor that expression. Okay, same thing applies here. We're going to start by factoring this, the left-hand side of this equation here, and then we're going to go ahead and set it equal to 0 so that way we can find the solutions. Okay, if you still need to factor it this way, go for it. I'm going to look at and show you guys and review how to factor it, actually keeping the cosine trig functions in here. You decide what works best for you. Just remember at the end, if you are only using x to help you factor it, at the end you must replace it again with cosine in order to finish actually solving the equation. Okay, so I'll review factoring quick for this example. So we want to multiply that 2 and that 2. We get 4. So now we're looking for two numbers that multiply to give me positive 4, but add to give me negative 5. I'm going to keep that 2 cosine squared x the same. So those two numbers would be negative 4 cosine of x and negative 1 cosine of x. And then we're keeping that plus 2 the same at the end. So negative 4 times negative 1 gives me positive 4. Negative 4 plus negative 1 gives me that negative 5. Now we're going to factor by grouping. So for the first two, I can factor out a 2 cosine of x, leaving me with cosine of x minus 2. For the second two, I'm factoring out a negative 1. leaving me with cosine of x minus 2. And so now my two factors, 2 cosine of x minus 1 times cosine of x minus 2 equals 0. Okay, so that's my that left-hand side of that equation in factored form. Now we need to actually finish this by solving by setting both of these factors equal to 0. So I'm going to have 2 cosine of x minus 1 equals 0, and then cosine of x minus 2 equals 0. And I'm going to isolate the cosine in both of these equations. So I'm going to start over here on the left. So I'm going to start by adding 1, and I'm not showing all the steps this time. So I added 1, then I'm going to divide by 2, and I get cosine of x equals 1/2. Let's solve the other equation over here. Cosine of x, add 2 to the other side, cosine of x equals 2. So now I'm looking for what x is for both of these equations. So let's start on the left-hand side here where cosine of x equals 1/2. So cosine of x equals 1/2 at the angle pi over 3 and at the angle 5 pi over 3. So those are two solutions. So over here, cosine of x equaling 2. Well, if we look on the unit circle, we're not going to find any values where cosine of x equals 2. If we think back to the way cosine looked when we graphed it, our amplitude for regular cosine was always at, it always went up to +1, -1. So 2 is actually out of the range. So there are actually no solutions here for where cosine of x equals 2. No solutions there. It's out of the range. The only solutions are where cosine of x equals 1/2, and that's going to be pi over 3 and 5 pi over 3. So you are going to see sometimes when you're solving these ones that end up giving you no solutions. That's okay. There are going to be times when you see that. Okay, I'm going to stop there for this screencast. I am going to be posting another screencast where we look at a little bit more information about solving trigonometric equations, so be sure to check that one out. Stay tuned.